Hey kids, welcome to section 4.4, graphing polynomial functions. Today you're going to learn how to evaluate polynomial functions and to identify general shapes of graphs of polynomial functions. So first let's just review what a polynomial is. A polynomial is written in standard form when the values of the exponents are in descending order. Now, if those values are in descending order, then the highest exponent will be first. The degree of the polynomial is the value of the greatest exponent. The coefficient of the first term of a polynomial in standard form is called a leading coefficient. So for instance, here are several different polynomials. The first one is a constant. An example is the number 12. It has a degree of 0 because it has no variable, and therefore it is the leading coefficient. If you have a linear polynomial that's in y equals mx plus b form, you can see an example of 4x minus 9. The highest exponent is a 1, that's why the degree is 1, and the 4 is the leading coefficient. A quadratic would have a degree of 2. Notice that in descending order, the highest exponent is a 2, therefore the degree is 2, and the leading coefficient is 5. In a cubic, you're going to have a highest exponent of a 3, and so the degree is 3, and the leading coefficient is 8. This last line is just what a general polynomial looks like. It has a sub n minus 1. Those are all the coefficients. And then it has your powers x to the nth, x to the n minus 1, and so on as they go down to x to the 0. The degree is n, and the leading coefficient is a sub n. Again, that's the fancy mathematical version of what we just talked about. So let's take a look at these four functions and see if they are polynomials in one variable. If they are, then we're going to state the degree and the leading coefficient of each polynomial. So if we take a look at letter A, 5x cubed minus 4x squared minus 8x plus 4 over x. This is not a polynomial, and the reason why it's not a polynomial is because you are not allowed to have variables in the denominator. So this is not a polynomial. No variables in the denominator. You can also remember that another way to say 4 over x is 4x to the negative 1. And you're not allowed to have negative exponents either. All right, if we take a look at letter B, 5x to the 6th minus 3x to the 4th plus 12x cubed minus 14. All the values are in descending order. It's all only one variable. This looks like a polynomial, so we're going to say yes, it is. If it is a polynomial, we have to pick out the degree and the leading coefficient. So my degree is going to be the highest exponent, which is 6. And my leading coefficient is whatever the value is in front, and that's 5. So 6 and 5. All right, if you take a look at letter C, 8x to the 4th minus 2x cubed minus x to the 6th plus 3. First, rewrite it in descending order. So I have negative x to the 6th plus 8x to the 4th minus 2x cubed plus 3. If you don't rewrite it in descending order, you might be tempted to think that this has a degree of 4, when in fact it has a degree of 6. So this, yes, is a polynomial. The degree is equal to 6, and the leading coefficient is going to be negative 1, because that is what is in front of x to the 6th. If we look at letter D, notice that there is a 3xy. Now we're looking for polynomials in one variable, so this is not a polynomial in one variable. There is more than one variable. There is more than one variable. Awesome. Okay, so now that we know what a polynomial is, now that we know how to find its degree, we can talk about how a polynomial function is a continuous function that can be described by a polynomial equation in one variable. So a continuous function means that there are no breaks or gaps. Um, and if it has one variable, like we just saw in the previous example, you can't have an x and a y. The simplest polynomial functions of the form f of x equals ax to the b, where a and b are non-zero real numbers, are called power functions. So if you just had f of x equals ax to the b and you knew what a and b were, that's called a power function. If you know an element in the domain of any polynomial function, you can find the corresponding value in the range by inserting the known value and calculating the function. Well, that's true. You've known that before. If I said f of x equals x plus 7, and I said find f of 2, well, f of 2 would be 2 plus 7, and that's 9. So we're going to do the same thing with polynomials instead of just numbers. So this example says the volume of air in the lungs during a 5-second respiratory cycle can be modeled by V of t equals this really long cubic trinomial, where V is the volume in liters and t is the time in seconds. Find the volume of air in the lungs 4 seconds into the respiratory cycle. Well, in order to find 4, I notice that 4 is time in seconds. And so seconds is the letter T. So I need to plug the 4 in for T. So I'm going to let T equal 4. And I'm going to find V of 4 equals negative 0.037 times 4 cubed plus 0.152 times 4 squared plus 0.173 times 4. So you're substituting the value into the function, and then you're going to use your calculator and simplify. So if we type this in our calculator, we get 0.756. This is volume. Volume is measured in liters. So liters. All right. Now, sometimes you have to plug in stuff that's a little more challenging than just 4. And so we can also substitute in algebraic expressions. So let's take a look at number 3. We need to find g of 5a minus 2 plus 3 of g times g 3 times g of 2a. And we know that g of x is equal to x squared minus 5x plus 8. All right, so there's kind of two parts to this problem. There's g of 5a minus 2, and there's 3 times g of 2a. So if I can find those two pieces, then I'm going to add them together, and I'll get my final answer. So let's find g of 5a minus 2 first. So that means to go to the g function, and wherever I have an x, I'm going to replace it with 5a minus 2. So I have 5a minus 2 quantity squared minus 5 times 5a minus 2 plus 8. And now we got to figure out what this equals. Now 5a minus 2, remember, is like doing 5a minus 2 times 5a minus 2. Remember, you don't just share the square, but you actually have to double distribute. So if I do 5a times 5a, that's 25a squared. 5a times negative 2 is negative 10a. Negative 2 times 5a is negative 10a. Should probably put the other ones that I did. And negative 2 times negative 2 is positive 4. So that's the whole 5a minus 2 quantity squared. Now we're going to distribute the negative 5. So negative 5 times 5a is negative 25a. Negative 5 times negative 2 is a positive 10, and that plus 8 is just hanging out. Now let's see if there's any like terms we can connect and simplify. I have 25a squared. That looks like my only a squared. Then I have negative 10a minus 10a minus 25a. That's minus 45a. And then I have a 4 plus 10 plus 8. That's 22. All right, I'm going to put a little star by it because we'll come back to it. Now I need to find the second half, which is 3 times g of 2a. 3 times g of 2a. That means my 3 is going to hang out until I figure out what g of 2a is, and then I'm going to multiply it. So g of 2a means go to the g of x function and replace the x with a 2a. Notice I put 2a in a parenthesis squared because I have to remember to square the 2 and the a. So then minus 5 times 2a plus 8. So now I'm going to simplify the inside. So leave the 3 hang. 2a quantity squared means 2 squared, which is 4, and a squared, which is a squared. Then I have minus 10a plus 8. Now I can distribute that 3 to all 3 terms. 3 times 4a squared is 12a squared. 3 times negative 10a is negative 30a. And 3 times 8 is 24. And this is my second half, so I'm going to put a star by it. Now I'm going to take my 2 starred items and I'm going to add them together. And I'm going to get 25a squared plus 12a squared is 37a squared. Negative 45a minus 30a is negative 75a. And 22 plus 24 is 46. So we get 37a squared minus 75a plus 46. So it can get a bit tricky with the algebra, so just be careful as you're distributing and multiplying. All right, let's look at B. So B, we are trying to find h of negative 4d plus 3, and then we're going to subtract 0.5 times h of d. And our h of x is 2x squared plus 5x plus 3. All right, so let's do the first one, h of negative 4d plus 3. So we're going to leave the 2. We're going to substitute negative 4d plus 3, quantity squared, plus 5 times a negative 4d plus 3, plus 3. Now remember that negative 4d plus 3 squared, we are going to write it twice and double distribute. So negative 4d times negative 4d is 16d squared. Ooh, I forgot about the 2 on the outside. So that's 16d squared. Then I have to do negative 4d times 3 is negative 12d. 3 times negative 4d is negative 12d. 3 times 3 is 9. So that's the inside. I distribute the 5. 5 times negative 4d is negative 20d. 5 times 3 is 15. And a plus 3. All right, now I need to distribute that 2. So I'm going to do 2 times 16d squared is 32d squared. 2 times negative 12d is negative 24d. 2 times negative 12d is negative 24d. 2 times 9 is 18. Minus 20d plus 15 plus 3. One more step to collect like terms. I got 32d squared minus 24d minus 24d minus 20d is minus 68d. And then I have 18 plus 15 plus 3. That's 36. Put a star by it. Now we have two options for the second half. I can figure out what negative 0.5 h of d is and then add my answers like before. Or I can use the subtraction for after I get my two answers. I encourage you to do it now so that you don't have to worry about distributing it later. So I'm going to find negative 0.5 h of d. That negative 0.5 is going to hang out on the outside. And ooh, this one's really easy because all we're doing is substituting d in for x. So we get 2d squared plus 5d plus 3. Look how nice this is. All we have to do is distribute. Negative 0.5 times 2d squared is negative d squared. Negative 0.5 times 5d is 2.5d. And negative 0.5 times 3 is negative 1.5. Put a star by it. So now I'm going to add my stars. 32d squared plus a negative 1d squared is 31d squared. Negative 68d plus 2.5d is negative 70.5. My bad. No. Hold on. This 2.5d should be a negative. My bad. Okay, that's better. So now minus 70.5d. And then 36 minus 1.5 is 34.5. So 31d squared minus 70.5d plus 34.5. Awesome. All right, so now that we know how to substitute in quantities and algebraic expressions, let's try to put some of this stuff together. So remember from the past that real zeros occur at x-intercepts. So the number of times a graph intersects the x-axis equals the number of real zeros. Now, we have looked at constant functions. Those have a degree of 0. No variable, no degree. Or I should say, no variable, 0 degree. Then we've looked at linear functions that have a degree of 1. And linear functions can also go downward. We've looked at quadratic functions that can open downward in a parabola or open upward in a parabola. We have cubic functions, which look like a squiggle. Now we're going to add a quartic function, which has a degree of 4, kind of looks like a W. If it's a negative, it's going to look like an M. I guess I can put him here. So it can look like that. It can also look like that. It can look like that. It can look like that. And then finally, a quintic is a degree of 5. It can also look like that. So notice that whatever the degree is how many real zeros there are. So there's 1 right there. There's 2 right there. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4, 5. So we're adding quartic and quintic. Now also take a look over here. There are odd functions and there are even functions. Odd functions will always have at least 1 real zero. So odd functions are going to cross at least 1 time. Notice here a linear degree 1 has 1. A cubic degree 3 has 3. A quintic degree 5 has 5. They all have at least 1. The even degree functions may have any number of real zeros or none at all. So notice that a constant function has no real zeros. Quadratic function degree 2 has 2. A quartic degree 4 has 4. So we have odd polynomial functions and even polynomial functions. Odd polynomial functions, look, it kind of looks like it's going up in a straight line, like an x to the first. And it looks like it's going down like an x to the first. Also, take a look at the evens. This is opening down like a parabola, except with more squiggles in the middle. This is opening down like a parabola, but with some squiggles in the middle. So we have odd degree polynomials and we have even degree polynomials. Only even degree polynomials can have no real zero. All right, if we look at this graphic, this is kind of reviewing some of the different things that we've talked about as well. Notice we have even degrees and odd degrees, and we have positive leading coefficients and negative leading coefficients, and behavior is coming back. And then notice we have domain is all real numbers for all the functions. And notice that parabolas have a minimum spot or a maximum spot, but the range for odd functions is all real numbers again. Couple of things to notice: the positive coefficient means it's opening up, the negative coefficient means it's opening down. A positive coefficient for the odd functions means that it's going in an upward fashion. A negative coefficient for odd degrees is that it's going in a downward fashion. Also notice that even degrees have endpoints at the top or at the bottom, but odd degree functions have them in opposite directions. That's huge. So let's take a look at the last two problems. Let's describe their end behavior. Let's determine if it represents an odd or an even degree polynomial. And then finally, let's state the number of real zeros. So if we look at letter A, our end behavior is as x approaches positive infinity, f of x is going to approach, well, as my x gets bigger, my y's get smaller. So I'm going to say negative infinity. As my x's get negative infinity, my f of x's are approaching, well, as my x's get smaller, my y's get bigger. So positive infinity. This is an odd degree polynomial because the end behaviors are in opposite directions. And this has 1, 2, 3 zeros. Oh, I guess this should say state the number of real zeros. So there are 3. All right, if we look at letter B, as x approaches positive infinity, f of x approaches, well, as my x's get bigger, my y's get smaller. So that's negative infinity. As x approaches negative infinity, my f of x is going to approach, well, as my x's get smaller, my y's get smaller. So also negative infinity. This has both ends in the same direction, which means it's an even function. It crosses the x-axis twice, so there are 2 zeros. All right, kids, if you have any questions, please let me know. And as always, keep calm and keep trucking.